This is Algebra 2, Unit 2, Lesson 4, on the domain and range of a function. Now, we did talk about domain and range back in Algebra 1, but let's see if we can figure out what this says. When you're talking about the set of inputs, the inputs, remember, are the x's. That is called the domain of the function. So any values of x, or inputs that work, are called the domain. The set of outputs, or the y values, is called the range. So the domains is the x's, or the inputs. The range is the outputs, or the y's. So let's consider the function that has its inputs as the month of the year and its output as the number of days in each month. In this case, the number of days is a function of the month of the year. Now that's an important statement right there. If we're assuming that this function is restricted to non-leap years, the number of days is a function of the month of the year. That saying is when you put in the months of the year, you get the number of days. So the input is the month of the year, and number of days is the output. Even though it just said that, it's a good reason to be reading for vocabulary purposes. So the number of days is a function of the month of the year. It says write in roster form the set that represents the function's domain. All right, a roster is basically a list. So if I were to make a set that represents the domain, what is the domain? Well, a domain is the inputs, which would be the months of the year. So that would be January, February, March, April, May, June, July, August, September, October, November to December. That would be your domain. So your domain would be months of the year. Now, when you put in the months of the year, you get an output of the range, which would be the number of days. In roster form, the set that represents the function's range would be the months of the year. So your range would be how many days are in a month. Well, let's see. February has 28 days. Most other months have either 30 or 31 days. So that is the range. So the months of the year is the domain. When you put in the months of the year, you get how many days. Domain, range. So these are all the options for the domain. This is all the options for the range. Let's look at a domain and range as a mapping. State the range of the function f of n equals 2n plus 1 if its domain is the set 1, 3, 5. Show the domain and range in the mapping diagram below. Okay, so the range of the function f of n equals 2n plus 1. What do they want you to do? They want you to find the outputs when your n's are 1, 3, and 5. So we are looking for f of 1, f of 3, and f of 5. So 1, 3, and 5 are the domain. To get the range, we have to plug 1, 3, and 5 into the function rule here. F of n equals 2n plus 1. So that means 2 times 1 plus 1 is going to be 3. So when n is 1, f of n, or f of 1, will be 3, and that is your mapping there. When you have f of 3, 2 times 3 plus 1 is 6 plus 1, which is 7. So when you have 3, the range is going to be 7. And then for 5, f of 5, when n is 5, 2 times 5 plus 1 is 11. So the domain is 1, 3, 5. What is your range? Your range will be the list of all the outputs. All of your outputs would be 3, 7, and 11. So that is an example of your domain and your range. Domain is the inputs, range is the outputs. All right, now, domain and range can also be found graphically. what you need to look at graphically are the maximum and minimum x values and the maximum minimum y values. So let's see if we can do this. We have the function y equals g of x is completely defined by the graph shown below. All right, determine the minimum and maximum x values represented on the graph. All right, so what we want to do is we want to find the highest and lowest x value on the graph. The easiest way to do that is to follow along the x-axis. And the x-axis runs left to right. So you want to go the farthest to the left you can and the farthest to the right you can. So if I draw a line like this, that's as far to the left as the graph will go. If I go farthest to the right, it would be here. So what is the lowest x value on this graph? Well, it would be right here. It would be at 1, 2, 3. X equals -3. That would be the minimum. The maximum x value, if we go from here over to here, this is 1, 2, 3, 4, 5, 6. This is x equals 6. So from here to here along the x-axis, that is how far the lowest x value, the highest x value. All of the values of x that we have for this graph fall between -3 and 6. So x min would be this one, and this would be x max. Now, we can do the same thing with the y values. Let me do a different color here. Let me do it in yellow. The highest and lowest y value. Well, the lowest y value is down here. Follow the y-axis. The lowest y value is right there. The highest y value is right there. That is the highest. So if I go on the y-axis, I want to find the values highest and lowest. So what is your minimum y? What is your lowest y? Well, that would be this point right here. This would be at -1, 2, 3, 4, 5. Is it -5? What is your highest y value? Your highest y value would be this point right here, 1, 2, 3, 4, at y equals 4. Okay, so notice this box that I created. The left and right, with the x values running left to right, from lowest to highest, would be the domain. The y values from lowest to highest would be the range. So if I want to state the domain and range of this function using set builder notation, that's using the inequality symbols and stuff. So the domain, where do the x's fall? Well, in set builder notation, it would be the x's such that x falls between -3 and 6. The left and rightmost x value would be that. So x would be less than or equal to 6, but greater than or equal to -3. And that is set builder notation. You may also see an interval notation. You would list it, -3 and 6 are included, so it would be from -3, comma, 6 with brackets because they're included. This is called interval notation. You may see this as well. Okay, this is set builder, this is interval. Let's look at the range. Well, remember the range is the y values. The y values fall between which values? Well, the lowest y value is -5. The highest y value is 4. So your domain is between -5 and 4. If you do it in interval notation, it'd be -5, comma, 4. If you box in your function, highest and lowest values, the left and right are the domain, and up and down is your range. So highest and lowest x's is domain, highest and lowest y is your range. Now, you can have functions that have domains and ranges that stretch out to infinity. All right, so look at this exercise right here. This function is f of x equals x squared minus 2x minus 3. It's graphed in the grid. Now, based on what we know about domain and range, see if you can answer that question. We'll come back to this and go over it during class the next day. Now we're also going to look at functions when they have defined by an algebraic formula. The domain will consist of the set of all real numbers given the concise symbol capital R. It looks like this. Sometimes it'll look like this. That means all real numbers. Now, there are exceptions to this. There's restrictions placed on the domain by the structure of its formula. So let's take a look at a couple of the basic restrictions. We have the function f of x equals 2x plus 1 over x minus 4. And here are the inputs, and here are the outputs. All right, so what is f of 1? What are they asking you to find? They're asking you to find the value of the output when the input is 1. So what is f of 1 according to this table? Well, f of 1 when x is 1, f of x is negative 1. And what is f of 6? When x is 6, the output is 6.5. So there are your values from that. Now, why does the calculator give an error at x equals 4? Notice this value right here. We found f of 1, we found f of 6, but when you find f of 4, you get an error. All right, let's look at the structure of the equation, or the expression right here. 2x plus 1 over x minus 4. If I plug in x equals 4, what happens to the denominator? Well, let's look at this. If I have f of 4, that's equal to 2 times 4 plus 1 over 4 minus 4. 2 times 4 plus 1 is 9. 4 minus 4 is 0. What's wrong with this? It is undefined. You can't have a 0 in the denominator. You can't divide by 0. Remember my poster in the front of the room, thou shalt not divide by 0? You cannot have a 0 in the denominator. So if you can't divide by 0, that makes it undefined. So that x value of 4 will not work. So if you have any value that'll make this undefined, then that cannot be included in the domain. So x equals 4 cannot be in the domain. Are there any values except x equals 4 that are not in the domain? Well, is there any other value that we plug in here that's going to make that 0? No, that's the only restriction we would have. So this is no. All other values are fine. All values except x equals 4 are real numbers and part of the domain. So that would work. So if we were to describe the domain of f for this is going to be x such that x is a real number. X is an element of the real numbers as long as x cannot equal 4. So your domain would be all the real numbers except for 4. It doesn't matter if it's 10, if it's negative 2, if it's a fraction, if it's a decimal, as long as your denominator is not 0. All right, denominator cannot be 0. So if you are looking for the domain, you are looking for all the values that work. But be aware of the ones that make the domain not work. Those are the exceptions. Okay, and for the last question, which of the following values of x would not be in the domain of the function y equals the square root of x plus 4? Think about this question. Remember, the domain are the values that work. For a square root, what values do not work? Explain your answer. So we will talk about this in class tomorrow as well. All right, so that's all the notes for today.